Good day, students. Today, we are going to learn what is an empirical formula. Before I go on to teach you what is an empirical formula, let's do a short recap. One of the important things that you must be able to know before you attempt this topic is that you must recall for me that to find the number of moles can be found by taking the mass of a substance and then dividing this by either the relative molecular mass or the relative atomic mass. This is a relationship that you must remember. Now, let's go on to understand what is an empirical formula. Consider for me now the case of a glucose, which is actually a C6H12O6. Student, this is the molecular formula of your glucose. To obtain the empirical formula of your glucose, all I need to do is to reduce this to the simplest form. What I do is I'll consider the numbers here, in this case 6, 12, and 6. I'll find a number that I can divide them to make them the smallest. So in this case here, what I will do is I will divide carbon by 6, so it gives me C1. Hydrogen, I will then divide by 6 as well. It will give me H2. And oxygen, after dividing by 6, will give me O. This, student, is the empirical formula . And it shows us two things. Number one, it gives us the types of elements that is present. And number two, it tells us the ratio which they are in. In order to get the empirical formula from the molecular formula, we simply reduce everything to the simplest term. And this is how you can actually get the empirical formula. Students, now, before I move on, it is important for you to understand how to obtain the molecular formula if you are given the empirical formula. So, what happens over here is an empirical formula, in this case here, will give you a certain relative molecular mass. In this case here, this relative molecular mass would actually be equals to 12, which is 1 carbon, plus 2, which is from 2 hydrogen, and plus 16, which is actually the relative atomic mass of 1 oxygen. If you add them up together, you will actually get the relative atomic mass as 30. Now, students, there will be some situation where you are given the relative molecular mass of the molecular formula. So, for example, if you do not know the molecular mass of your glucose And all I tell you is that the molecular formula of glucose actually has a relative molecular mass of 180. I would then be able to understand that with your MR, there's 180 here, and the MR of the empirical formula. In order to find the molecular formula, all I need to do is to multiply it by 6. How do I get this 6? This 6 is obtained when I actually take the relative molecular mass of molecular formula and I go on to divide this whole thing here by the relative molecular mass of my empirical formula. So in this case here, this is actually 180, and I divide by, in this case here, this is actually 30, and as a result of this, you will find that this is actually equals to 6. So in this case here, when I take my empirical formula CH2O and I multiply everything by 6, I will then be able to find the molecular formula, which is actually C6H12O6. And that, student, is how you can obtain your molecular formula from your empirical formula. Usually, in the question, you will be given the relative molecular mass of the molecular formula. In this part of the e-learning, you have actually learned how to obtain a molecular formula from the empirical formula and vice versa. But however, in nature, you do not always have this data at first. Consider the case of a magnesium oxide. Now, students, what we do know about magnesium oxide in terms of its formula is that it contains magnesium, and we also know that it definitely contains oxygen. However, we may not know, okay, what is the number here. So, we usually will obtain the empirical formula through mass calculation. Now, allow me to show you an experiment that will allow us to determine the empirical formula of magnesium oxide. What we can do in the typical experiment is that we can set this up here. So this, student, is a crucible. It's a small container where you can put in some magnesium ribbon, and then you can cover this with a lid. You can then subsequently support this and go on to put it under heating. Student, always remember, when we are talking about burning, your mind should always consider the possibility of burning being a reaction with oxygen. So now, when we come to weighing the mass, we will first have the mass of an empty crucible plus the lid. And if you refer to with me to your textbook, in the context of this example here, the data that is given is assuming that when we weigh it, this is actually 26.52 grams. Next, what we will do is we will put in some magnesium ribbons. Okay, magnesium, these are magnesium ribbons. What we will do is this. We will weigh them together, and according to your data in your booklet, when the mass of my empty crucible and the lid plus magnesium, the weighing balance actually tells us that the reading is 27.72 grams. Now, when this happens, based on this alone, right, we will then be able to tell me, you will be able to tell me that the mass of my magnesium is actually 27.72 minus 26.52 grams. And that, students, will allow me, if you press your calculator, to find out that the mass of magnesium is actually 1.2 grams. Now, subsequently, after burning, we go on then to weigh it all again, and we find that the mass of our crucible lid plus the resultant magnesium oxide that is formed now has a combined weight of 28.52 grams. That, student, will allow us to determine that the mass of my magnesium oxide is actually equals to 28.52 grams minus this number here, 26.52, and that, student, will give me 2.00 grams. Students, if you consider now with me the mass of my magnesium oxide as well as the mass of my magnesium, you will find that the difference is really just caused by the presence of oxygen. So in this case here, if I were to now take 2.00 minus away 1.20 grams, this will give me 0.80 grams, and this, student, is actually the mass of my oxygen. So now, once I actually obtain the mass of my oxygen and the mass of my magnesium, I would then be able to do a calculation that tells me the formula of my magnesium oxide. So how do we do this? What we will do is this. Since we know that I have magnesium as well as my oxygen, I know that in terms of mass, I've actually contained, I have 1.20 grams, and oxygen is actually 0.8 grams. I will then convert my mass to moles. Now, to do that, I will utilize what I have learned in the front just now, which is I will divide my magnesium with the relative atomic mass of magnesium. In this case, all I need to do is to take 1.20 divide by 24. This 24 is actually the atomic mass of magnesium. And for oxygen, I will take 0.80 divide by 16, which should be the relative atomic mass of oxygen. So this would then give me 0.05 to 0.05. In order for me to obtain the mole ratio, what I will do is I'll take these two numbers and divide by the smaller of them. In this case, it happens that since both of them are the same, I'll divide both by 0.05. And after I divide them by 0.05, okay, I would then be able to get the mole ratio. Take this, divide by 0.05, I'll get 1. And take this, divide by 0.05, I'll get 1. Now, this mole ratio over here tells me that for every 1 mole of magnesium, I will have 1 mole of oxygen. And as a result of this, I can now conclude that this magnesium MgXOY has a formula of, well, MgO. And this, student, would then allow me to determine the empirical formula. Let's recap that in order for us to get a molecular formula, we may need to have more data. We will need to have the molecular mass. But however, in this case, through this analysis, okay, of actually doing the calculation from the mass itself, we will then be able to calculate out the empirical formula. Now, before you go on to try the assessment, I would like to give you one more example before we go on to do the assessment. Students, now let us take a look at your textbook, page 150, example 2. Students, let me work this out together with you. If you take a look at this, the question states that this compound by the name of glycerol contains by mass 39.1% carbon and 52.2% oxygen. The question is, they want us to find the molecular formula. Now, so what happened in this case here? First, let's find the empirical formula. In this question here, I'll approach by doing this. 39.1% by mass of carbon, 52.2% by oxygen simply tells me that percentage by mass of hydrogen is 100% minus 39.1% and minus 52.2%. And that would give me a percentage of 8.7 by mass of hydrogen. Students, what this means to you that in order for you to do calculation, I need to think of it this way. If they tell you that it is 39.1% by mass, this simply means that in 100 grams of glycerol, right, what I have is actually 39.1 grams of carbon, 8.7 grams of hydrogen, and 52.2 grams of oxygen. This means that with this mass, I can then go on to convert this into moles. To find the moles, all I need to do is to divide the various mass by the relative atomic mass of the atom that they are. So in this case here, to find the moles of carbon, I'll take 39.1 divided by the AR of carbon, and that would actually give me 3.3 moles. For the case of hydrogen, 8.7 divided by 1, that gives me 8.7 moles of hydrogen. And for the case of oxygen, all I need to do is to take 52.2 and divide by 16. And that would give me 3.3. In order for me to get the mole ratio, right, what I actually need to do is to divide these numbers, these three numbers here, these three numbers, by the smallest of them all. So in this case, it would be 3.3. So to get the mole ratio, what I'll do is I'll take 3.3 divided by 3.3, okay, and that will give me 1. In this case here, 8.7 divided by 3.3, that would give me roughly, okay, around 2.6. In this case here, 3.3 divided by 3.3 will give me 1. So, students, in this case here, once we actually get this kind of numbers, right, the idea is that we really want to change it into such a way that this number here, okay, can actually be a whole number. So in order for me to do so, right, one of the best ways is to multiply this by 3, okay. If I were to multiply this by 3, this becomes 3. When I take 2.6 and I multiply by 3, right, what I will get is a very close approximate to 8. And this is 3. So as such, I can tell you very confidently that the empirical formula of glycerol is actually C3H8O3, and that would be the empirical formula. Now, we are not done yet. So now we have the empirical formula. We will then need to determine the molecular formula. Now, I want you now, as I'm erasing the board, to take a look at the question again. Now, the empirical formula we have actually determined to be C3H8O3. The question tells us that 1 mole of glycerol weighs 92 grams. Class, when 1 mole weighs 92 grams, it simply means that the MR, okay, or for that matter, the molar mass of my glycerol is actually equals to 92.0. Now, let's recall that the molecular formula is actually equals to a multiple, let me call that multiple n, times the empirical formula. Now, in order to find n, this n is actually equals to the molar mass, the relative molecular mass, okay, of the molecular formula divide by the relative molecular mass of the empirical formula. So in this case here, the relative molecular mass is actually 92 that is given. Now, the relative molecular mass of my empirical formula is actually 3 times 12, okay, plus 8 times 1 plus 3 times 16. So when you do that, you'll find that actually this number here turn out to be 92 as well. So this becomes 92 divided by 92 and equals to 1. So in this case here, this n is actually equals to 1. So which means that if you take the empirical formula, this whole thing here, and you times 1, that will give you another C3H8O3, which in this case here turns out to be the molecular formula of my glycerol as well. So as a result of this, in this case here, it turns out that the empirical formula equals the molecular formula. And with this is how you can actually solve questions that relates to the empirical formula. Thank you.